The cloud. Got it. Okay. Share content, screen. Okay, so what we do today is first we'll go over some homework questions you might have, then some review. I guess I'll make some remarks and we'll take it from there. Are there particular questions anybody wants to talk about? Or maybe a sort of quick recap. Last time I did the probability mass function for jointly continuous random variables that I considered the probability mass function for function two variables. That should be capital Y. Also written as P of X sub I, Y sub J, can be written in different ways. Remember what this means, the probability that we want to find probabilities like X equal to K, Y equal to J. We talked about how one finds the expectation of a product as a double sum. And in fact, the easy way to do this is to take all possible products and multiply them by their corresponding probabilities. And we should know when X and Y are independent, then we have E of XY equals E of X, E of Y. That was an interesting result. Why do we need this? Because sometimes we want to compute V of X plus Y. In order to compute V of X plus Y, you need to know a couple of things. You need to know V of X plus V of Y plus 2 times E of XY minus E of X, E of Y. So you're given different kinds of problems. So sometimes you need to know E of XY in order to find V of X plus Y. Other times you're given V of X plus Y and you want to find E of XY. And you can do that because you're given, once you have E of X squared, E of Y squared, you can figure out V of X, V of Y, E of X, E of Y. You need to determine E of X quantity Y. So that's why it's important. All right, let me go back and straight. Are there questions about any homework exercises you had? Really? Nobody had any questions?
I have page.
You got to speak louder. I can't hear you.
Oh, sorry. Page
Don't be sorry. Just speak louder. Hold on. Let me turn up my volume a second, okay?
Okay.
If I turn up my volume, I might be able to hear you a little better. All right, turn up my volume.
Okay, page 114, number 13.
Page 114. I didn't hear the number.
Number
114.
13.
Would you say it again, please?
Yeah, 13.
13. Page 114, number 13.
Yeah.
Consider the following game. A die is tossed. If the number 3 or less, you win $4. Hold on, where's my note? You say if you get a 1, 2, or 3, the die is tossed, you win $4. If a 5 or a 6, you lose $3. 5 or 6, you lose $3. Okay. And if a 4 occurs, you get nothing. Okay. Okay, so what's your expectation? How could you change the rules to make the game fair? Okay, so what do we know? So the probability of getting a 1, 2, or 3. So here, so what are the possibilities? Let's write them all out. The x of i's. 1, 2, and 3. You win $4. This is the winnings. And here are the corresponding probabilities, right? 1/6, 1/6, 1/6. If you get a 5 or a 6, you lose $3. These are also 1/6 and 1/6. If you get a 4, which I'll put over here, doesn't make a difference where I put it, you win nothing. Okay, so the expected winnings, W is the expected winning, right? So E of W would be 4 times a 6 plus 4 times a 6 plus 4 times a 6 minus 3 times a 6 minus 3 times a 6 plus 0. So the expected winnings, what do we get? 4, 8, 12. 12 less 6 is 6. So what do I get? 1? On the average, did I get it up right? 4, 4 is 12. 12 minus 6 is 6. 6, okay. So I didn't make a mistake just now. On the average, your expected winning is $1. So how can you make this game fair? Well, we know that E of W plus a constant is equal to E of W plus a constant, right? Now we want this to be fair, so this should equal to 0. Well, we know this is 1. 1 plus what is equal to 0? So to make it fair, we subtract $1 from every winning. So if you get a 1, 2, 3, you win $3. If you get a 5 or 6, you lose $4. And if you get a 4, you lose $1. That would do it. Okay? Does that answer your question?
Yeah.
Okay. Anybody else have any other questions on this?
Yeah, Professor, I have a question on number. It's going back a few sections though. I think it was.
I don't care. Just tell me page and problem number.
Gotcha.
Who am I talking to?
Yeah.
Okay,
So
okay.
I had a question about number 9 on section 2.5, page 90.
Page 90, number 9.
Oh, I have a question.
Okay, a player wins a contest if he can win 2 consecutive games played alternately with opponents A and B. Hold on, let me, I just lost my screen. Wait a second. Okay. A player wins a contest if he can win 2 consecutive games played alternately against A and B. The probability of beating A a quarter, and the probability of beating B is 4/5. I'm just putting down the information so I have it. If he plays no more than 3 games, determine the probability he wins if he plays A first or B first. Which one do you want me to do, A first or B first?
We do B first.
B, okay, sure. So he either plays B, he beats B. So the probability he wins if he plays B is 4/5, right?
And the probability that he loses to B is 1/4. Wait, yeah, 1/5.
1/5, okay. Now if he beats B, now he plays A and B. If he beats A, if he beats A, the probability he beats A is what, 1/4?
Yeah.
Now, what happens here? Let me just read the rules again. By the way, if this happens right here, oops, then he stops because he won 2 games in a row, correct?
Correct, but I'm a little bit confused with the wording because it says that he plays 3 games.
He plays at most 3 games. Hold on. So a player wins a contest if he wins 2 consecutive games, played alternately with opponents A and B. Okay. So right here he's done. Because he's won 2 games. Agreed?
Agreed.
Now what about here? Well, here no matter what he's done, if he
if he wins or loses.
Now he would play B, or he loses to B, but it doesn't make a difference. In either case, it's over. So we want to know what's the probability to win, right? So in this case, what happens in this case right here? Does he win or lose? He loses, right? He played 3 games and he didn't win 2 consecutive games.
Correct.
Same thing here. He loses.
So it doesn't really matter if he wins or loses as long as like the games he played at least 3 or more.
Either in order for him to win this, he either wins 2 consecutive, like here. Okay, here he wins. Or here, A prime. And then there's B prime. Notice here, he wins again, right? Because he won 2 consecutive games. And here, no matter what, he loses. So he wins, how many ways can he win? He wins this way. Why don't I get my red? He wins on this path, correct? This is 1/5. What was A again? A was
1/4. And then B was 4/5.
So there are 2 paths where he wins. So the probability he wins is 4/5 times 1/4 plus 1/5 times 1/4 times 4/5, whatever that is. And the other one is very similar. Okay. Three dice are tossed. Determine the mean and expected value and variance. Is this a hard problem or an easy problem? The one I just wrote up. Either I toss a die 3 times, or I toss one, or I toss 3 dice once. Doesn't make a difference. What's the mean? And hold on. X equal the sum of all the spots. I want you to find E of X and V of X. How did we do this one? Anyone? Is this a hard problem or is this an easy problem?
Professor, is that are you trying to find expected variations or expected?
One more time. 3 dice are tossed. Here's how I would ask the problem on an exam. 3 dice are tossed. And the sum of the spot, X is the sum of the spots, okay? Of the 3 dice. What's the mean? What's the expected sum? What's the expected and what's its variance? We've already done it with 1 die, and we've already done it with 2 die. You don't remember. In fact, I work it out with case n equals 2 right in the book. Okay, so there are 2 ways of doing this problem. One way, of course, there's 6 times 6 times 6 possibilities, right? 36 times 6, whatever that is, 216, whatever that is. But that's the hard way. The easy way is the following. Let X sub I equal of the number of spots on the ith toss. Okay? Remember, so there are 3 of them. There's X1, X2, and X3. And the sum will be the sum of these. Now let's look at any one of them because they're all the X of I are identical and independent. So if you look at X of I, what are the possibilities? 1, 2, 3, 4, 5, 6. And the corresponding probabilities for any one of these is 1/6. So E of X of I is 1 times a 6 plus 2 times a 6 up to 6 times a 6, which is what, 3/2? Did I do that right? 6 and 5 is 11, 11 and 7 is 18, 19, 20, 21 divided by 6. 3 goes 2, 3 goes 7/2. Okay, 7/2. So I know for each of these, E of X of I is 7/2. So E of X is therefore equal to sum of these. Which is what, 21/2. Similarly, you find E of X of I squared. 1 squared times a 6 plus 2 squared times a 6. I forget what that turns out to be. Hold on. I think I have it worked out already. Turns out to be 91/6. So V of X of I is 91/6 minus 21/2. Oops, wrong one. 91 over 6 minus e of x squared. And that turns out to be, by the way, I do a similar calculation on page 111 of the text. 35 over 12. 35 over 12. And therefore, by independence, v of x is v of x1 plus x2 plus x3, which turns out to be just 3 times 35 over 12, or 35 over 4. So that was probably the easy way of doing that problem, using independence. The other way is to look at all possible sums, and it's a lot of work. All right, I just threw that in because it happened to come up. Other questions anybody has? This is the time to ask. Remember, the stuff starts at what, Bayesian in the exam, remember correctly? The exam starts at section 2.4, and it goes through whatever we just finished. 2.9. Yes.
I have a question on page 91, number 16.
Page 91, number 16. Elizabeth and Joshua toss a fair coin successively. I'm sorry, 19 you said?
Yeah, no, 6.
I'm sorry, which one was it?
16.
16. The first to toss a head keeps the coin. Joshua goes first. Okay. So what could happen? Joshua could win on the first toss, right? If Joshua goes first. Or, I'm just looking at the cases now. Joshua could lose, what's the other one's name? Elizabeth could win, okay. So let me say it a little differently. Joshua could win on the first toss, right? Or he could win on the third toss. Remember, they're going alternately. Or he could win on the fifth toss, and so on, right? In order for him to win on the first toss, what must happen? He gets a head, right? In order for him to win on the third toss, it means he loses on the first toss. That's the probability he loses, but happens to be half, right? Is it all half? Yeah. It's a fair coin. Okay. Then Elizabeth loses on the second, and then Joshua wins on the third. Or he loses on the first, she loses on the second, he loses on the third, she loses on the fourth, he loses on the fifth, and so on. So the sum of all these probabilities is the probability that Joshua wins.
Professor, I think we're trying to find if Elizabeth wins.
I'm sorry?
I think we're trying to find if Elizabeth wins. Elizabeth keeps the coin.
What's the difference if I find Joshua or Elizabeth? Is it one that complemented the other? If Joshua wins, then Elizabeth loses. And by the way, since it's a half, it's not going to make a difference in this problem.
Oh yeah, good point.
So this is a half.
I didn't see that.
Plus an eighth. Plus 2 to the, I lost a place. 2 to the fifth. So let me factor out a one half. Okay. Now, this is a geometric series. R is equal to what? What's R?
1/2.
A quarter. So the probability is first term over 1 minus R. 4/3. Okay. 3/4 makes up 4/3. Okay. Here we go. It was an interesting problem because both Joshua and Elizabeth had the same probability. Okay?
So Elizabeth is also 2/3.
I can't hear you.
So Elizabeth is also 2/3.
Yeah.
Oh, okay.
It's because it was a fair coin.
Wouldn't Elizabeth be 1/3? Because she's a compliment to Josh.
No, I'm sorry. It's a compliment would be 1/3. Yeah.
Oh, okay.
Next question.
Professor, in 2.9, can we do question number 4? Or actually number 3?
2.9 number
132, question number 3.
Given the random variable, okay, number 3 went there, right? So you're given the X and Y, and you're given that the joint PDF P of X sub I, Y sub J is equal to K X sub I, Y sub J squared, where X sub I is 1, 2, or 3, and Y sub J is, I lost a place, 1, 2, 3, 4. Okay. So he asked a whole bunch of questions. So there are a couple of ways of doing this. I mean, I could do, if I want, I can put the formula in it like so here. So X takes on the values 1, 2, 3. And the Y sub J takes on the values 1, 2, 3, 4. So let's put down the probabilities. We don't know K. Okay? So if X is 1 and Y is 1, what do I get? What do I plug into the formula? What do we get? If X is 1 and Y is 1, I just get K, correct? If X is 1 and Y is 2, 2 squared is 4, I get 4K. Everyone see where I got that from? I'm substituting into this formula for X and Y. If X is 1 and Y is 3, I get 9K. And when X is 1 and Y is 4, I got 16K. Here I get 2K. If X is 2 and Y is 2, 2, 4, 8, I get 8K. If X is 2 and Y is 3, 9 times 2 is 18. If X is 2, if X is 2 and Y is 4, 16 times 2 is 32K. Oops. X is 3 and Y is 1, I got 3K. X is 3 and Y is 2. 4 is what, 12K? 3, 9, 27K. And 4 is 16. 16 times 3 is 48K. Okay, so 16 and 9 is 25, 25. This is 30K, right? 30 across. 32 and 18 is 50, 60K. 48 and 27 is 75, 75, 85, 90K. Make sure I'm adding up right, okay? I'm doing this in my head. This gives me 180K. And I got to be 1. Let's check in the other direction. 6K, 24K, 45, 54K, 96K. Does that check? 96 and 54 is 10. 96 and 56 is 10. 15, 150. 115, 30, 100. Okay. So I know the sum of all the probabilities have to be 1, right? So 180K must equal 1. That tells me K is equal to 1 over 80. 1 over 180. So I'm using the fact that the sum of all the probabilities must total 1. So I now have K. What else do I have to do here? Find E of X. Well, E of X is the following. I'm going to leave the K in for a moment. 1 times 30K plus 2 times 60K plus 3 times 90K so what's that? 90, this is 60, 120 is 150, 150, and I just screwed out in my head. Hold on. 30, so what do I have? I have 270 and 120, 270, 370, 470. I don't believe I can't add right now. 120, 270, and 30, 0, 12. So what's this, 420K? But K is equal to 180. So 6 goes 3, 6 goes 7. Okay, 7/3. Assuming I didn't make a mistake there. E of Y is done the same way. It would be 1 times 6K here. 1 times 6K plus 2 times 24K plus 3 times 54K plus 4 times 96K. Add this up. Remember, K is 180. And you got the answer. So let's see what would be interesting here. How would you find E of XY? Okay, so E of XY would be all possible products times the probability. So what are the possible products? It would be 1, 1 times K plus 1, 2 times 4K plus 1, 3 times 9K plus 1, 4 times 4k. Remember, k is 1 over 180. Now, 2, 1 times 2k plus 2, 2 times 8k plus 2, 3 times 18k plus 2, 4 times 32k plus 3, 1 times 3k plus 3, 2 times 12k plus 3, 3 times 27k plus 3, 4 times, what's the place, 48k. Remembering k is 1 over 180, this would give you e of x and y. So I think I've answered most of the, oh yeah, another example in this problem might be the probability that x less than 3 given y greater than or equal to 2. Well, that's equal to the probability that x is less than 3 and y is greater than or equal to 2, divided by the probability that y is greater or equal to 2. The probability that x is less than 3 and y is greater than or equal to 2. The probability that x is less than 3 and y is greater than or equal to 2. Well, where would that be? If x is less than 3 and y is greater than or equal to 2, let's say, if x is less than 3, we have to be in the first row line or second line, and y is greater than 2, it would be some of these numbers, right? In this group, x is less than 3, and y is greater than or equal to 2, so it would be some of these 4 numbers. That would be the numerator. And the probability that y is greater than 2, for y to be greater than 2, y must be 3 or 4.
Professor,
Yeah.
why we don't include 2 for y?
Y greater or equal to 2. What do you mean? I do have it here. Oh, I'm sorry. You're right. It is great. It should be. You're right. It's this one. Thank you. I didn't read my own handwriting. Okay. And the probability that y is strictly greater than or equal to 2 would be the sum of these 3 numbers right here. That would give it to us. Thank you for the correction. Other questions?
Page 123, number 12.
How many times should a bias coin with probability of a head if you want the relative frequency of heads, okay, you want what's the probability that the relative frequency of heads, I lost the place now, differs from the probability by less than 0.01. Okay, now I don't expect you to memorize this and work this out, but if you'll notice on page Oops. I prove on page 120 that the probability of the relative frequency of an event differing from its probability differs by the amount A is always greater than or equal to 1 minus P times 1 minus P over N A squared. Okay? That's example. Look at example 2 on page 120. Don't bother memorizing that, please. Okay. So in this case, this is number, where is it, 12?
Yes.
Yeah.
So in this case, we want A to be, I lost the place again here. We want this probability to be at least 95%. Right, is that what it said? How many times should coin, so if we want at least a 95% probability that the relative frequency is different by less than 0.01. And we want A to be 0.01. So all we have to do is set the following. We know P in this case is equal to 0.6. N is what we want to find, and A is 0.01 of it. And let's set this equal to 0.95. Let's find the integer that will do it. So it'll be at least 95%. What does that give me? That gives me 0.05 is equal to 0.24 over N times 0.01, or this is equal to what? 0.5 over 100. I hate decimals. Divided by 24 over N. Let's hope my arithmetic is right. This is 1 over 20. So N is equal to, cross multiply, 480. Check my arithmetic. So that is at least 480, it'll work. Now, it wouldn't be a problem on exam because I don't need to memorize formulas like this. But this was just an application of Chebyshev inequality. Next question. And by the way, if you didn't know P, suppose you didn't know what P was. So then remember, P times 1 minus P is always less than or equal to a quarter. You'll just see then what you have is 1 minus 1/4 over N. A squared is, by the way, I made a mistake. This should have been squared. Okay. So let me fix the arithmetic up. If I fix that up, so it's 0.05 equal 0.24 over N times 0.01 squared. So it's another factor of 100 here. And you'll see, compute this number, then compute this number, and you'll see when you don't know what P is, N has to be much larger. That's what would happen here. Okay. Next question. Don't be shy, folks. This is your time to ask.
Let's go with 2.4. Let's go with question number 8.
Three different loan examiners review the application, blah, 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 blah. Each reviews 1/3 the applicants. Okay. So there are three people here, A, B, and C. Probability you got A, B, or C is a third. Mr. A rejects 25%. So he accepts, I'll have to say 75%. B rejects 40%. And C rejects 60%. Okay. Mrs. North's application is rejected. So given her application is rejected, what's the probability that Mr. Blank made the decision? So notice you're being told that it was rejected, the end of the tree, and you want to know about the cause, the Bayesian problem. So there's just P of B and R divided by P of R. B and R is what here? So that's 1/3 times 0.40 over the probability to be rejected, which is three different ways, which is 1/3 times 0.25 plus 1/3 times 0.40 plus 1/3 times 0.60. So what does that give me? It gives me 40 over 40, 100, 125. I do that right, 60, 40 is 100, 125, okay, and 5 goes 8, 5 goes 8 over 23. No, that's wrong. 5 goes 8, 5 goes 8 over 25. How's that? Double that is 250. Okay. All right, I did the arithmetic quickly, but the problem is a pretty straightforward problem. Straightforward Bayesian problem. Other questions? Okay. By the way, if you want to see a fun problem, fun is in your definition. The last problem on page 35 was a problem that made a lot of news years ago in the newspaper, in the Parade magazine. It was called the Monty problem. And I don't know if you're familiar with the old program on TV, but it's based on that. So you might want to look at that. I do the solution for you. It's posted. I think I do it a couple of ways. Other questions?
So what page again?
On page 85, the last problem, number 12, the Monty problem. It's all about choosing doors in a quiz contest or something.
Yeah, isn't that the problem where if you choose a door, no, if they eliminate one door, you always switch because.
Well, that's for you to figure out why. The answer is why, and that's correct. That's what it's about. But it threw a lot of people. A lot of people didn't understand how to do that problem. That's why it's here.
But doesn't the game show host like also ends up like part of the probability because he already knows what door has what?
I don't want to talk about the problem now. If you want to look at it, it's all here. Okay. Yeah, but that's what it's all about. Okay, are there other questions?
Page 102.
Yeah.
Number 11.
102, you said?
Yeah.
Where's example 3?
Example 3 is on page 101.
No, example 3 is the one in the text, isn't it?
It's
This is
page
example.
94.
Page 90. Yeah.
Yeah.
In the previous example, so let me find the previous example. I got to go back a couple of pages. So we toss a coin how many times? 3 times? Let me make sure I understand the question. Which one am I doing again? Number
11.
11, yeah.
So the random variable in example 3, and example 3, and x is what? X equals to the number of heads. Okay. So if we toss a coin 3 times, we can get what? No heads. One head, 2 heads, or 3 heads, right? And the corresponding probabilities of getting no heads, that's getting all tails. These would be the probabilities, right? So here's my distribution. Okay, so now we want the CDF. Remember, the CDF.
Wait, Professor, wouldn't the third one be 1/8?
1/8, yes, thank you.
Okay.
Is P of X less than or equal to X. So, I want to find the CDF. You want a formula, you want a graph, or both? Notice I can do it both ways. So here, let's do that. Let me do the graph in black. So until you get 0, nothing happens. At 0, the probability is 1/8. It stays 1/8 until you get to 1. At 1, it jumps. It jumps up 3/8 to 1/2, right? If you add 3/8 to 1/8, you get 1/2. That's at 1. It stays at here until you get to 2, not quite 2. And then it goes up another 3/8 to, what was that, 7/8? It stays there until you get to 3, and it goes up 1/8 to 1. So there's a graph of the CDF. Or you could say this way, f of x is equal to 0 if x is less than 0. Then it's equal to 1/8 if x is greater or equal to 0, but less than 1. And then it goes up to 1/2 if x hits 1, but less than 2. Then it goes up another 1/8 to 7/8 if x is 2, but less than 3. And it's 1 if x is greater than or equal to 3. So there's the formula, if you want, for the same graph. Notice it's an increasing function. And also notice, for example, the jump at each of these points is equal to the probability that x equals that value. This jump is equal to the probability that x equals the value at the jump. So there's your graph. So either one is fine. Sometimes they want both. Other questions? Going once. Going twice.
We go with 2.9 again. Let's go
what
with
about 2.9?
Which cross? Can you go with number 6?
Suppose x and y are independent random variables. The fact that they're independent, the problem is trivial. You don't really have to do any work. Let me explain why. If they're independent, if I give you these two random variables that are independent, suppose, well, firstly here, well, let's do the problem and you'll see what I mean. So first I give you x of I, which takes on the values 1, 2, 3, and p of x of I, 0.4, 0.5, 0.1. And then there's the y's. Takes on the values 1 and 2. And probabilities are just 0.3 and 0.7. Okay, so suppose I want to find e of x. Well, that's just 1 times 0.4 plus 2 times 0.5 plus 3 times 0.1 as an example. Similarly, e of y would be 1 times 0.3 plus 2 times 0.7. Now, suppose you wanted to find the joint PMF. You're being told that x and y are independent. So what are the possibilities? There's P11, P12. I mean, there are 6, P13, and so on. Notice, for example, if I wanted to find P32. Since they're independent, that's equal to P3 times P2. P3 was given as what? 0.1. The probability x equals y equals 2 is 0.7. So you get 0.07. You get all of them this way. Suppose I wanted to find P21. Well, that's equal to the probability x equals to 2 and y is equal to 1. The probability x equal to 2 is 0.5. The probability y is equal to 1 is 0.3. So you got 0.15. Even this term is trivial, e of x, y, because they're independent. It's just e of x, which we figured out, times e of y. So the problem's solved, basically. So this problem is really a lot easier than it looked because they were independent. Okay. Other questions? Okay, so let me at least end this class with first let me remind everybody that I'll send you instructions for the exam, same as the last time. Make sure your COVID is all accurate, you're allowed in. It's on the 5th floor. I don't remember the room number, but I'll send it to you. Get there early. Okay. One result I want to do, one trivial result's really nothing new, but I want to make an observation. Okay. Firstly, I want to observe the following. I want to show you that this expression, this product, is in fact what we're going to call the covariance. So let's work this out. So if I use the properties, basic properties of arithmetic, I get xy minus mu sub y times x minus mu sub x times y plus mu sub x mu sub y. And this is equal to E of xy. Remember, mu sub x and mu sub y are constants. And since this term is a constant, I'll just write plus mu sub x, mu sub y. Let's rewrite this a little more. Minus mu sub y, now E sub x is another way of saying mu sub x. Minus, I lost something. Okay, we're good. Plus mu sub x, mu sub y, plus minus mu sub x, mu sub y. Notice this term cancels this term, and I'm left with E of xy minus, now this one term, let's just rewrite this as E sub x, E sub y. So we just proved the following identity. We just proved that E of x minus mu sub x times y minus mu sub y is equal to E of xy times minus E of x, E of y. So you can take this as a theorem if you like, but it's just what this says is we give this a name. This is called the covariance. And it can be written two different ways, as I just shown you. And by the way, sometimes you'll see the symbol sigma sub x, y. So the covariance is defined to be this expression right up here. And why is it important? Well, it's not as important as people make it out to be. Because what it does, it tells us, if you look at this, it sort of, okay, I left out a parenthesis here. It sort of tells us how x and y are related in some sense. We want to define some kind of relationship, whether it's a linear relationship or not, between the random variables x and y. And we'll say this is a measure, one measure by which we can do it. I'm going to talk about this in some detail the next time. But I want to make an observation, okay? So if you just look at this expression, which we now call the covariance, and I've used this word a couple of times before. Firstly, notice the covariance of x and y. If I interchange x and y, They're the same. That's the first observation. The second observation is, if I replace y with x, then I get the variance of x. Why is that? Because we get e of x squared minus e of x times e of x. So that there's a sort of a relationship between the variance and the covariance. The covariance is because it's a relationship between two random variables, x and y. So the questions one asks, if there are certain relationships between x and y, what can you tell me about the covariance? Well, it turns out that the covariance is not a really very good measure of a relationship, because the covariance can take a number, can be any number between minus infinity and infinity, so it doesn't give you a good feel for what the covariance is going to measure, which I haven't talked about yet. But we're going to see that we can normalize the covariance in some sense. I just lost a place. What the hell happened to my note? Okay. And what do I mean? I want to remind you that we learned a while back, if you take any random variable x and you subtract its mean and divide it by its standard deviation, we transform this into a new random variable, which we call a standardized random variable. Okay, a standardized random variable. And it's going to turn out, if we do the same thing for y, it turns out that when we look at this random variable instead, there's a lot of information. We're going to show that this is a nice bounded function, meaning it doesn't get too big and it has very good behavior, and it tells us a relationship. In fact, you'll see that this is going to be essentially the correlation coefficient, whatever that might mean. I don't know how many of you had statistics or but these ideas, the idea of regression, come up a lot in statistics, and it's going to be based on correlation coefficient. So we'll talk about that. How's my time here? I don't want to do any more about this right now, but there really is nothing new about what I just said. That is, I could have asked you as an exam question to prove, and when I use the word prove, students get nervous, that E of x minus mu sub x, y minus mu sub y equals this result. This is an important result. We're going to need it. And the reason we need it is, well, it's pretty simple. Sometimes it's easier to interpret this expression, this first expression, than this. Because if it turns out that this product is positive, okay, x minus mu sub x, y minus mu sub y, if that's positive, that means that x and y are behaving the same way. Either they're both increasing above their mean or both decreasing beneath their mean. So it says they're growing in the same way in some sense. If it's negative, if the inside product is negative, then it means one is getting larger and one's getting smaller. And that has interpretations that we'll need to talk about. Okay, that's as far as I'm going to go today. We're reviewed. You'll be ready for your exams. Please get there early. Let me go back to here. Are there any questions anybody has about anything else?
Professor, yeah, I have a question on
I have a question too.
Okay, one at a time.
I'll go Andrew, you want to go first and then I'll go after?
Oh yeah, mine's more of a logistical question. Wait, I'm sorry. Oh yeah, mine is more of a logistical question. So, is it possible if you could post all the information about the test on Blackboard? Last time you said you were going to do that, but
What do you mean, what all information? Where to
just
go?
like a test time, and yeah, I have
The
to go
exam
right now.
starts at supposedly 10:45. I'm going to ask you to start earlier if you can get in there. You had trouble getting into last time.
Yeah, there was a little bit of trouble.
All right,
But
I'll try it. Well, we'll see if we can handle that up.
Yeah, so on Blackboard, is it okay if you could post all the information about the test and whatnot, and what we need to bring?
What do you need to bring? Bring your brains, your pencil, paper. You can use a calculator if you like.
Okay.
What else is there?
I don't know. Just because I forgot the room number and I was having trouble and I looked.
I will send it to you. I don't remember. I think it's 520, but I'm not sure.
Is it the same? It's the same room, right?
Same room. Yeah, it's supposed to be.
Okay. Thank you.
So you'll get the information. I'll send it out in a day or so. Any other questions? Anybody?
Are we
Yeah,
allowed
Professor.
to bring like? Oh, sorry.
If you came in late,
Go
send me
first,
an
go.
email.
Just a quick question. Are we allowed to bring like formula sheets?
No,
Okay.
no formula sheets. There's no need for it. Any other questions?
Yeah, I had a question on page 115, number 25.
Hold on, let me just see if I can do that quickly for you. 115. All right, what about it?
So in order to prove it, right? What?
All right, I'll tell you how to do it. Are you listening?
Yeah.
Call AX plus B Y for a second. You listen, you have V of Y is equal to E of Y squared minus the quantity E of Y quantity squared, right? That's the definition of variance. Got that?
Yeah.
Okay. Now replace Y by AX plus B. And then multiply that and use the properties of expectation. That'll do it. You'll see that the A terms, so you're just going to get A squared times B of X. That is translating, and if you think about it geometrically, if you add B to any score, all that does is shifts the whole histogram left to right by B units. So that means the spread around the mean is the same. The mean is changed, it's moved by B units, but the spread around the mean is the same, which means B doesn't affect the variance, the constant B. Work it out. You'll see. I worked it out for you in your notes as well.
All right. I'm going to check it out.
Okay. Other questions?
Thank you, Professor. Have a good one.
Okay. Those of you who came in late, you'll let me know by email and I'll fix up the attendance. Have a good day, everybody.
Have a good day, Professor.
Oh, I got to turn off the recording.